Okay, so I'm doing the free response from 2006, number 5. So, as you see in part A, well, first we have the differential equation dy dx equals 1 plus y over x. So with part A, it says, on the axes provided, sketch a slope field for the given differential equation at the 8 points indicated. So, to get points on that, you just draw the slopes on the graph, as you can see. To get the points, which is a total of 2 for part A, the sign of the slope at each point and the relative steepness of the slope of the lines in the rows and columns have to be correct. So to get the slope of the line at each point, you pick one of the points, let's say 1 of 0. 1, 0. So we have y plus 1 plus y, and the y in this situation is 0, over x, which is 1. So 1 plus 0 equals 1 over 1 equals 1, which means that the slope at point 1, 0 equals 1. So you just draw the slope accordingly. And for maybe another point in the negative area, let's say negative 1, 0, we have 1 plus, again, 0 over negative 1, which is the x. So the slope will be negative 1. So you draw a negative 1 slope accordingly. And you do that for each of the points, and make sure, like I said, that the steepness and the sign of the slope are correct to be able to get all of those points. In part B, it says, find the particular solution, y equals f of x, to the differential equation with the initial condition f of negative 1 equals 1, and state its domain. So, first of all, when you see a question like this, you have to separate the variables. Just separating the variables gets you 1 point. So, as you can see, you separate the variables into 1 over 1 plus y. Well, you make sure that the x's are all on one side and the y's are on one side. So you have 1 over 1 plus y dy, which equals 1 over x dx. So after that, you have to take the antiderivative of it. So for, as we know, ln of x, the derivative of that is 1 over x. So if you're taking the antiderivative, it would be ln of the absolute value of 1 plus y equals ln of the absolute value of x plus k. And so to get rid of the ln, you have to exponentiate both sides. So once you do that, you get rid of the ln on the left side. So you will just be left with the absolute value of 1 plus y, which equals e to the ln of the absolute value of x plus k. So then, after that, you get 1 plus y equals c to the absolute value of x. C ultimately becomes 2 after you put in the initial condition. So you have 1 plus y, which equals 1, which equals c to the absolute value times the absolute value of x, which is -1. So that equals 2 equals c, because the absolute value of -1 is 1. So c times 1 is 1, c, and 1 plus 1 is 2, so 2 equals c. So then you put c in, substitute 2 into c, and you'll get 1 plus y equals 2 times the absolute value of x. So when you solve for y, you get y equals 2 times the absolute value of -1. Or, since we're in the domain of x is less than 0, you could say y equals -2x minus 1. So the domain will always be x is less than 0. And you have your answer.